Good day, greeting students, and welcome back to the video tutorial for the subject Science 10. This is again Sir RJ Olarve, and for this quarter, we are going to have the new branch of science, which is chemistry. And for the first chapter, we are going to have gas it up. So from the title of this chapter, so we're going to tackle gases. And did you know that among the three phases or states of matter, which are solid, liquid, and gas is known to be the state of matter which was easily identified and studied by the early scientists? Well, that's the fact. And for this chapter, we are going to focus on the different nature of gases, the different properties of gases known as the general properties and the measurable properties of gases, and also the different laws that govern the behavior of gases. And for the first lesson, we are going to have introduction to gases. And before we have the discussion proper, let us have first the different lesson objectives. So in this lesson, you are expected to come up with the following objectives. First is to know the kinetic molecular theory of gases. Second is to familiarize yourself with the different properties of gases. And lastly is to know the measurable properties of gases. And for the introduction, let us have first a definition of matter. So we all know that matter is said to be anything that occupies space and has mass. Okay, and when we say the space that was occupied by a certain matter or material, that is what we call volume. So therefore, we can say that matter is said to be anything that has volume and has mass at the same time. And it can be classified according to the following physical states of matter, which are liquid, solid, and gas. And gases, on the other hand, as one of the physical state, are said to be the least compact and most mobile of the three states of matter. So when we say least compact compared to the solid and gas, the molecules of the gases are very far away from each other. Therefore, it is said to be the least compact of all the three phases of matter. And it is also said to be the most mobile of the three states of matter. When we say mobility, so it talks about the movement of the molecules or particles of gases. And therefore, gas molecules move with very high velocity and thus have high kinetic energy. So take note of the domino effect, no? Given that it is the least compacted of the three states of matter, it is also the most mobile of the three states of matter. And because it is the most mobile of the three states of matter, so the molecules of gases are said to really move at a very high velocity, and it causes it to have a very high kinetic energy compared to the liquid and solid. Moreover, because of high velocities of their molecules, gases in a mixture are uniformly distributed within the container in which they are confined. So we are done with the introduction to gases, and now it is time for us to have the general properties of gases. So what are the general properties of gases? Actually, there are only 5 general properties of gases. And what are these? So first is, gases have no definite shape and volume. So when we say it has no definite shape and volume, because the shape and volume of a specific gas is dependent on the container on which it is being placed. Second general property is gases diffuse readily and easily, thus make it easy to combine completely with other gases. Given the fact that the molecules of gases are very far away from each other, so the moment na yan ay na-release sa surrounding, so it will easily diffuse or kakalat agad yan, and it will make it easy to combine with other gases that are present on the surrounding. So example nito is kapag tayo ay napautot. Okay, so nakakatawa man yung example ko, pero just for example nga is napautot ka, so definitely yung particles ng utot mo will combine completely with the other gases on the surrounding. So bakit siya maaamoy agad dun sa medyo malayong parte? Okay, so dahil nga ang gases has the ability to be diffused readily and easily on the surrounding. And third general property of gases is that gases can be compressed easily because of the large amount of the space between the molecules of gases. And given the fact that the particles of gases are very far away from each other, So it will also cause the gases to be compressed easily kasi nga malawak pa yung spaces between the molecules or particles of gases. And number 4 is gases have much lower densities compared to the solids and liquids. So when we say densities, it talks about how compacted the molecules or particles of a given substance or matter. So for example, ang may pinakamataas na density is the solid kasi nga the molecules and particles of solid are very near from each other. So sumunod dyan ay si liquid and then gases yung pumangatlo sa kanya which has the lowest density compared to the solid and liquids kasi nga yung kanyang molecules are very far away from each other and it will result for it to have a lower density. And last general property of gases is the forces of attraction between the molecules of gases are said to be insignificant. Dahil nga sila ay freely moving, okay, so sila may pinakamataas na kinetic energy, so hindi rin talaga gaano ka-significant yung interaction between the molecules and particles of gases. And take note that all the molecules in the solid and liquid state, they are actually exhibiting forces of attraction, but this time in the gases or in the gaseous state, so the forces of attraction are said to be insignificant. Meron pero hindi natin siya kayang ma-identify kung gaano yung level ng forces of attraction na nag-e-exist between each molecules. So we are done with the general properties of gases. And now it's time for us to have the kinetic molecular theory of gases. Because in order for us to explain the behavior of gases, we use what we call kinetic molecular theory of gases. And the word kinetic, it refers to the motion or movement of the molecules which constantly move and fly about in all directions. Especially here in gases dahil nga malawak or far away yung particles niya. So definitely kayang constantly move yung mga particles or molecules ng gases. And this theory pictures each gas molecules as a tiny particle, and a molecule will collide with an object in its path, such as another molecule on the walls of the container. So example nito is kapag nagpalobo ka ng lobo, okay, yung particles ng gases na nasa loob nun will really have an interaction with the wall of the container or dun sa wall ng balloon. Another thing about the kinetic molecular theory of gases is what we call principal assumptions of the kinetic molecular theory of gases, which explain how the molecules of gases behave. So what are these? So first, gases are consisting of tiny molecules or particles. Second is the distance between these molecules is larger than the size of the molecules themselves. So, ibig sabihin nito, kung maliit or sobrang liit na ng molecules, so mas malaki yung size ng distance between each molecules compared to the size of each molecules. And third is the gas molecules are said to be in a constant, rapid, and random motion. So, hindi mo talaga kayang ma-identify, kaya nga din yung interaction between the molecules of gases are very insignificant or said to be insignificant kasi nga these molecules are in constant, rapid, and random motion. So, hindi mo kayang ma-identify saang direction siya pumupunta or gumagalaw. Next, number 4 is the average kinetic energy for molecules is the same for the gases at the same temperature, and its value is directly proportional to the Kelvin temperature. And lastly, number 5 is there is an significant or no force of attraction between and among gas molecules. As I've mentioned, dahil nga sobrang laki nung distances between each molecules, so nag-cause yan para magkaroon ng insignificant or at some point no force of attraction between and among gas molecules. And those are the different principal assumptions of the kinetic molecular theory of gases. And now let's proceed with the different measurable properties of gases. But first, what are measurable properties of gases? So when we say measurable properties, these are properties of gases which pertain to the properties of gases which can give you a numerical value. Ibig sabihin, kaya nga siya measurable, meron tayong ma-encounter ng mga computation para ma-express natin yung specific na behavior ng gas na yan. That is why it is also called as the quantitative properties of gases. And what are the different measurable properties of gases? So there are five. And what are these? So first is pressure, second is volume, third is temperature, fourth is the amount of gas, and fifth is density. And we are going to discuss them one by one. So let's start off with pressure. So pressure is the first measurable property of gases, which is expressed using capital letter P. And another thing about pressure is that it is defined as the force per unit area, wherein the pressure of a gas is equal to the force exerted by the gas on the walls of its container divided by the surface area of the container kung nasaan yung gas natin. And we use the formula wherein P, or the pressure, is equal to the force over area. And another thing about pressure is it is measured with the use of a device called the barometer, which was invented by the Italian physicist and mathematician named Evangelista Torricelli, 1608-1647. And here, this barometer was the first barometer consisted of a basin with a long tube filled with mercury. Kasi yung magagamit natin ngayong mga barometer, wala na yung mercury. Pero yung pinakaunang ginawa ni Evangelista Torricelli is actually propelled using a mercury. And here is figure 1-3 showing the mercury barometer invented by Evangelista, wherein ito yung ating mercury reservoir or yung ating basin kung saan ito yung mag-hold ng mercury na magpo-propel or magkapagana sa ating barometer. While on the other hand, this figure 1-2 shows us how a specific gas escape from a balloon in order for that balloon to be propelled by that escaping gas. And speaking of pressure of gases, actually pressure of gases is expressed using different units, among which are the following. So we have atmosphere, or the ATM, the torr, millimeter of mercury, or the mmHg, and the pascal, or the PA. And this table shows the different conversion of unit, okay, under the pressure. So ito, 1 atmosphere is also equal to 760 torr, which is also equal to 760 millimeter of mercury. So therefore, kung ang isang atmosphere is equal to 760 torr, 760 millimeter of mercury, so therefore 1 torr is also equal to 1 millimeter mercury. And 1 atmosphere is equal to 101,325 Pascal. And dahil nga tayo yung makaka-encounter dito sa measurable properties of gases ng iba't ibang computation or conversion of units. So this time, let us have the first example of how are we going to convert 16 atmosphere to torr. Okay, using this table, so analyze nyo muna yan. So alin kayo yung pwede natin gamitin na conversion? Given daw ay atmosphere papunta sa torr. So pwede natin gamitin is 1 atmosphere is equal to 760 torr. Wherein ang gagawin nyo dyan is just copy 16 atmosphere. But this time, instead of writing equal sign, you are going to replace it with a multiplication sign. And then, i-multiply nyo yan sa 760 torr over 1 atmosphere. So, paano nyo malalaman kung sino ang ipiplace nyo dito sa baba or dito sa denominator? So, kung alin yung kada-diagonal niya na unit, yun yung dapat nandito sa baba para makancel natin siya. So, kaya ang nandito sa baba is atmosphere para pag pinag-multiply mo yan, makakancel natin yung atmosphere dito. Okay? And then, ang answer dito, okay, 16 atmosphere multiplied by 760 is equal to 12,160 torr. So, therefore, 16 atmosphere is equal to 12,160 torr. So, ganun lang kadali mag-convert ng conversion kapag direct yung pag-convert mo. But what if meron tayong 3 torr and it will be converted to Pascal? So, analyze muna natin dito. So, wala tayong direct conversion ng torr papuntang Pascal. Pero meron tayong atmosphere papuntang Pascal. At ang una nyo munang gagawin dito is i-convert nyo muna itong si torr papunta kay atmosphere using itong 1 atmosphere is equal to 760 torr. So, ito siya. 3 torr, ayan siya, papunta kay atmosphere kasi nga need mo munang makuha yung atmosphere na unit para ma-convert mo siya papunta kay Pascal. So indirect kasi yung conversion na to. Okay, so kailangan nandito si torr sa denominator para ma-cancel natin siya. So 3 multiplied by 1 divide 760 will give you an answer of 0.00399473684 atmosphere. So atmosphere pa lang yan. Ang kailangan natin is the Pascal. So kaya naman, itong naka-convert natin sa atmosphere will be used para ma-convert natin yung atmosphere papunta sa Pascal. Where inikopy lang natin yun, 0.00399473684 atmosphere multiplied by 101,325 Pascal over 1 atmosphere. Again, dapat diagonal sila para makancel natin yung atmosphere. And it will give you the answer 399.97 Pascal. So therefore, 3 torr is equal to 399.97 Pascal. So that is all about pressure. Nakaka-pressure na ba? First measurable property pa lang yan, no? Nung naka-encounter tayo ng simple conversion and indirect conversion, ayan, na-pressure na tayo. Pero don't worry, madali lang to, yung mga susunod natin ng mga conversion. And let us have the second property or measurable property of gases, which is volume. So volume is expressed using a capital letter V, wherein volume also refers to the space that gas occupies. And the volume of the gas is the volume of its container that is based on the principle that gas molecules occupy all the spaces available. So kahit na meron tayong large na distances between or sa pagitan ng mga molecules of gases, so we still consider na yung space doon sa loob is actually the same volume na inoccupy nung mismong gas na yon. Okay, and another thing is that the volume occupied by the gas molecules is negligible. Ibig sabihin, insignificant yan compared to the volume of the container. And also, the common units that are used to express volume are cubic centimeter, liter, and milliliter. And we use this conversion wherein 1 cubic centimeter is also equal to 1 milliliter, wherein 1 liter is also equal to 1,000 milliliter. And let us have a sample conversion. So 2.34 milliliters is how many in cubic centimeters? So una muna, tingnan natin kung ito nasa table, wherein from milliliter papunta sa centimeter. So pwede natin gamitin itong 1 centimeter or 1 cubic centimeter rather is equal to 1 milliliter. So isa-isa lang yan. Pwede naman natin siyang isulat directly, pero still, I want you to familiarize yourself kung paano ba natin siya kino-convert, no? Wherein, copy mo lang siya, 2.34 milliliters multiplied by 1 cubic centimeters over 1 milliliter. Again, diagonal. So, cancel yan. And the answer is 2.34 cubic centimeters. So, di ba, basic lang? But how about magkaroon ulit tayo ng example ng indirect conversion wherein ipapadaan mo muna yung given unit natin sa isa pang unit para makuha natin yung hinihingi. Okay, so let's have what is 2.34 liters in cubic centimeters. So, una muna, analyze natin to. Okay, yung nasa box natin wherein sabi doon liters yung given. Papunta daw sa cubic centimeters. Wala tayong direct conversion. Okay, kaya naman, ito munang si 2.34 liters ay i-convert natin papunta sa milliliters. Kaya naman, pag nakuha natin yun, pwede natin siya i-convert kay cubic centimeters. So, una muna, copy. Okay, 2.34 liters multiplied by how many? 1,000 milliliters over 1 liter. So, cancel. It will give you the answer 2,340 milliliters. Pero hindi pa yun yung final answer. Itong value na to is i-convert pa natin papunta sa cubic centimeters. So, ngayon, 2,340 milliliters multiplied by 1 cubic centimeter over 1 milliliter. Diagonal, cancel. So, it will give you the answer 2,340 cubic centimeters. So, therefore, 2.34 liters is also equal to 2,340 cubic centimeters. And that is all about volume. And now let's have temperature. So temperature refers to the quantitative measure of how cold or how hot something is, specifically a gas. And among gases, the unit Kelvin is the absolute temperature that we use in the measurement. Kasi kadalasan siguro nakikita nyo sa mga temperature is degrees Celsius, degrees Fahrenheit. Pero this time, Kelvin ang gagamitin natin as the absolute temperature in the measurement of the temperature of gases. And in the cases where degrees Celsius is given, okay, we use the formula below in order for us to get the value of Kelvin, wherein Kelvin is equal to degrees Celsius plus 273. And let's have a sample problem. So what is the K temperature or the Kelvin temperature of 35.6 degrees Celsius? So una muna sa lahat, okay, is kunin mo yung ating formula, which is ito. Okay, so Kelvin is equal to degrees Celsius plus 273. Tingnan mo yung problem natin. Ang given dyan is degrees Celsius. So, i-substitute mo lang si 35.6 papunta dito sa ating formula, wherein it will give you equals 35.6 degrees Celsius plus 273. So, add mo lang yung dalawa and it will give you the answer 308.6 Kelvin. And number 4 measurable property of gas is the what we call amount of gas, which is expressed using a small letter n. And this is the amount of gas that is being measured, which is always expressed using moles or the letter n. And take note that at standard temperature and pressure, or the what we call STP, 1 mole of a gas occupying a volume of 22.4 liters. And we use the formula wherein N or the moles is equal to mass, which must be expressed in grams, over the molecular or the molar mass or the mm of a given compound or element. And now, we are down to our last measurable property of gases, which is density. So density, so naka-italic na letter P yan, or yung parang papaganito siya na letter P. Ayun. So now, density is referring to the mass per unit volume. And the common units are gram per milliliters, gram per cubic centimeters, and gram per liter. And that is all about density. And as a recap about the different measurable properties of gases, so again, we have 5. And what are these? So we have pressure, volume, temperature, amount of gas, and lastly is density. And that is the end of our module number 1 for the 3rd quarter under the subject chemistry. And if there are things that are unclear to you, feel free to message me at any of these accounts. So Facebook, Gmail, and cell phone number nandyan naman. So feel free to contact me. And as a reminder once again, in 1 Corinthians 10 verse 31, so when you eat or drink or do anything else, always do it to honor God. So God bless grade 10 in answering all the activities under this module. So see you on our Zoom meeting this week. God bless grade 10.